Welcome back to my channel. Here we are going to look at how to plot the locus of a point that moves so that its distance from two fixed points which are 50 millimeters apart is always in the ratio 2 to 1. How to plot the locus of a point that moves so that its distance from two fixed points which are 50 millimeters apart is always in the ratio of 2 to 1. Now, let's look at what we are to do with this for us to plot the locus of that moving point. So what we are to do first is to draw a horizontal line. So we draw a horizontal line. Okay. So we are going to fix the 2 points. So we are going to fix the 2 points. So we take a measurement of 50 millimeters. Okay. So the distance between the two fixed points is 50 millimeters. So here we have the first point, okay? Then we take 50 millimeters forward. This is 50 millimeters, okay? So here we have the first point. Let's call this first point. Let's call it point A. So this is point A here, okay? And the second point, let's call it point B. So this is point B here. So we also need to locate another point. So another point, so we should also be 50 millimeters from this point B here. So we take 50 millimeters forward again from point B. So this is 50 millimeters. So let's call this point, let's call it point C. So here we have this point to be point C here. Okay, so we have this. Now, so since we are told that the ratio of the movement is 2:1. The ratio of the movement is 2:1. So what we are to do is that we are going to divide the distance between these two fixed points. We are going to divide it into 3 equal parts. So we are dividing into 3 equal parts because 2 plus 1 will give us 3. So we are going to divide the distance into 3 equal parts. So we have this, okay? So I'm going to take a measurement. So a measurement here. I'm going to take a measurement, so I'm going to divide into 3 equal parts. That is distance AB into 3 equal parts. I'll take 20 millimeters. This is 20 millimeters. This is another 20 millimeters, and here we have another 20 millimeters here. Here we have another 20 millimeters. This is 20 millimeters. So we join the last point. So we join it with point B. So here we join with point B. Then taking my set square, so bringing my set square to this point, so and then we draw a line, so we move it to this point, okay? Then we draw a line from here to touch this. So this is in ratio 2 to 1. So this is in ratio 2 to 1. So this point here, so let's call this point. So this point here, so let's call this point. Okay, so let's call this point, let's call it point V. So let me call it point V. Okay, so as we have here, so the next thing that we are going to do is for us to get the ratio, is for us to get the number for the movement, as we are told that the ratio of movement is 2:1. So just look at what I'm going to do. So let's start with, so let's say what we have, that from point A. So let's write it here. So for point A, so we have point A here, and then we have point B here. So we are going to do it this way. So since the movement is 2:1, so this is 2 and this is what? This is 1. So let's take note of this. So I hope you can see what I'm doing. So here we have, let's say this is 40. So if this is 40, this will be 20. Okay, so that will be 20 then. So if this is 50, so if this is 50, so this will be 25. So here we have this will be 25. So if this is 60, so this will be 65. Sorry, this will be 30. Sorry, this will be 30. Then if this is 70, so this will be what? This will be 35. Okay, so we have 35. So it's in 2:1. And then if this is 80, okay, so this will be what? This will be 40. So let's take note of that. And then if this is 90, we will not use all. So if this is 90, this will be what? This will be 45. Let's take note of it. So everything is in 2:1 as I've listed it here. So you need to have this written down. So this is what we are going to do with the numbers that we have here. We will not use all. So let's start. So if we take what? We take 40 millimeters. So 40 millimeters on the ruler. Okay. So 40 millimeters on the ruler with the compass. Here is 40 millimeters. Okay. Then, so putting the pinpoint here at point A. So we are going to draw an arc. So we draw an arc up here and we draw an arc down here. Then, okay, so draw an arc down here. Then from point B, we have 20. So take a measurement of 20 millimeters from point B. So this is 20 millimeters. So take your time. So take it gently. So this is 20 millimeters here. So here we have 20. I want to make sure I have that distance taken perfectly. So this is 20 millimeters. So put the pinpoint here at point B, and then so draw an arc up here, and then draw an arc down here. So just do it gently. Next is 50. So if we take what, 50 millimeters, so here we have 50 millimeters. So this is 50 millimeters. So here we have 50 millimeters. So put the pinpoint here at point A, and then so draw an arc up, and then draw it down here. Okay, then from point B we take 25, so 25 millimeters. So I need to come here and take it. Okay, so this is 25 millimeters. Okay, so 25 millimeters. Here we have 25 millimeters here. Okay, then putting the pinpoint here at point B. So putting the pinpoint at point B, so we draw an arc here, and then we draw an arc here. All right, so next we go for what? We go for 60. So if we take 60 millimeters, so from here, so this is 60 millimeters on the ruler. So we take 60 millimeters. The compass will do 60 millimeters. So putting the pinpoint here at point A, so we draw an arc up here, and we draw an arc down here. Then so next, so we have 30. So we take 30 millimeters. That is from B. So we have 30 millimeters. This is 30 millimeters here. So then putting the pinpoint here at point B. So at point B here, we put the pinpoint here, and we make an arc here up, we make an arc here down. Okay. So next we have what? We have 70. So if we take 70 millimeters from 70 millimeters, so that is from A, 70 millimeters from, okay. So we put the midpoint here at A, and then we draw an arc up, and we also draw it down. Okay, so for B, we have 35 millimeters, so we take 35 millimeters. Okay, so this is 35 millimeters. Okay, this is 35 millimeters here, and then so putting the pinpoint here at point B, so putting the pinpoint here at B. Okay, so we draw an arc, so up here and also down here. All right, so then next is 80 millimeters. So we take 80 millimeters for A. So we take 80 millimeters. So I'm looking at what we have here. Okay, so we take 80 millimeters. Okay, so from A we take 80 millimeters. So this is 80 millimeters here. Okay, then so putting the pinpoint here at A. Okay, so make an arc up here. Okay, then we also make an arc down here. Okay, then for B, so we take 40, so 40 millimeters. So here I have this to be 40 millimeters. So this is 40 millimeters here. Okay, then putting the pinpoint of the compass at point B, so make an arc up here, we make an arc down here. Next is 90 millimeters. So we take 90 millimeters for A. 90 millimeters for A. So this is 90 millimeters. So here we have 90 millimeters. Okay, then putting the pinpoint at A here. So we draw an arc up here, and we draw an arc down here. Then we take what? We take 45 millimeters for B. 45 millimeters for B. So from this point, we take 45 millimeters. This is 45 millimeters here. So here we have 45 millimeters. Okay. Then so we put the pinpoint 45 millimeters. So putting the pinpoint at point B, so we draw an arc here, and also we draw an arc here. So if we take the last one, which should be 100 to what? 100 to 50, everything will rest here. So even once we take that of 100, it will touch this point, as you know that distance between point A and point C is 100 millimeters. So by the time I take that 100, it will just have the arc drawn on this line. So we don't need to do that. So all we need to do now is to join this point together to form the locus of that point, so which moves such that the ratio of the movement is 2:1. Is 2:1. So let's make sure we can see this point clearly. Okay, that's what I'm trying to do here. So we can see the point. Okay. All right, so we now need the French curve to bring out the shape of the locus. To bring out the shape of the locus, so everything will rest here, and also it will rest at this point V. Okay, so let's take the French curve to bring out the curve. So we take it slowly. So for me, as I have here, so I can join this point together. So we can join this point together like this. Okay, we have this point joined together. So we have this point joined together. Okay, so then I need to adjust it so that I can get the curve perfectly. Okay, so we have this now. So let's come to this side. Okay, all right, so we have this now. So let's come here and walk down here now. So we set the French curve. So we set it like this along the point, and then so I can take it from here to here now. All right, so we have this, and then so bringing it here like this. Okay, so we have this. All right, so this gives us the locus of the point. So we can see that it forms a circle. So this is the locus of the point as we have done it. It's as simple as I've done it here. All you have to do is to practice, and when you practice this, you become a master at it. I want us to do something. So let's connect this point. Let's connect it with this point. Okay, so connect this point with this arc here. Okay, so let's put an arrow edge. Okay, just to show that the radius from this point to this, for us to draw this arc, so this is 40. Okay, so this is 40 millimeters, and then from point from point B to this particular arc, so this first arc here, so distance from here to here, so the radius of this arc from point B. Okay, so as we have here, so this is 20 millimeters. Okay, all right, so you can see how simple it is to construct the locus of a point which moves so such that the ratio is 2:1. Thank you, and God bless you.